Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Today our group will present our project the call is project AC power analysis. Okay, this is our group's members. First, Tivarasan, anak lelaki Gandhi. Second, Nivash Kumar, anak lelaki Chandrasekaran. Third, Muhammad Syamil bin Abdul Rashid, and lastly is Musfirah Nasuha binti Saidi. Okay, next.
Okay, now I will go to my part, which is I need to give a brief explanation about current. There are two types of current, which is alternating current and direct current. So now I will give a brief explanation about AC circuit. So in AC, the electric charge change direct periodically. The voltage in AC circuits also sometimes reverses because the current change direction. However, it is easy to understand some AC concepts. Most houses are wired for AC. So, if your idea to connect your TARDIS Melody Box project to an outlet, you will need to convert AC to DC. AC also has some useful properties, such as being able to convert the voltage levels with a single components like a transformer, which is why initially we have to choose an AC means to transmit electricity over long distances. So now I will give a brief explanation about the application of the AC circuits. Home and office are almost or always used at high voltages like as over 110 kV. Less energy is lost in electrical power transmission. Higher voltages mean lower currents, and lower currents mean less heat generated in the power line due to resistance. AC can be converted from high voltages easily using transformers. AC is also capable of powering electric motors. Motors and generators are the exact same device, but motors convert electrical energy into mechanical energy. This is useful for many large appliances like refrigerators, dishwashers, and so on, which run on AC. That's all from me. Thank you.
Greetings to lecturer and everyone. Today I will explain about part calculation. First, we will give a look to our circuit. This is our circuit, and the question is we have to find average power absorbed by each of the components. So we have power supply, another power supply, resistor, inductor, and a capacitor. So we have total we have 5 components. And before we calculate the power absorbed, we have to determine the current flow. There is 2 power supply, so there is 2 current flow. First one is I1 and the second one is I2. To calculate the current through, we will use mesh technique. So if you can look the procedures in the slide. Firstly, mesh 1. We all know the Ohm's law, which is V equals to IR. Voltage equals to in current times resistance. So we will apply that Ohm's law in this mesh 1. So for the first I1, there is resistor and a capacitor. Resistor's value is 8 ohms and capacitor's value is negative J2. Okay, in the second part for the I2, there is capacitance in between I1 and I2. So we will include negative J2. So then we will get the first equation, which is 8 minus J2 I1 plus J2 I2 equals to 40 degree. And now for mesh 2, we will look the second part of the circuit, which is I2. So same technique, then we will get J4 minus J2 I2 plus J2 I1 equals to 90 degree. That will be our second equation. Then we rephrase the first equation, where then we get I2 equals to 40 0 degree over J2 minus 8 minus J2 over J2 I1. That will be our third equation. So now we have to substitute the third equation into the second equation. Then we get the value of I1, which is I1 equals to 5.59 with an angle of 153.435 degree amperes. Then that will be our fourth equation. Now we can substitute the fourth equation into the third one to get the value of I2. So if we substitute, the value of I2 will be 51.3 with an angle of negative 46.975 degree amperes. So using the value of I1 and I2, now we can calculate the average power absorbed by each component. First, we will calculate the power absorbed by first voltage source. The formula for the power absorbed is half Vm Im cos the degree of voltage minus the degree of current. So when we apply the formula, then we will get power for voltage source 1 and voltage source 2. The P1 is equals to negative 100 volt and the P2 is negative 375.05 volt. And for the resistor R1, we should find its voltage first using the Ohm's law, which is voltage equals to current times resistance. Then the answer will be 44.72 with the angle of 153.435 voltage. Then we substitute the voltage into the power absorbed formula. Then we will get our third power, which is 125 volt. The same goes to the inductor and capacitor, where the fourth power will be 0 volt and the fifth also 0 volt. Mostly the average power absorbed by the inductor and capacitor are 0. This is because in this circuit, the inductor and the capacitor are called purely reactive impedance. The purely reactive impedance absorb no average power and they are often called lossless elements. The purely reactive network operates in a mode in which it stores energy over one part of the period and releases it over another. Therefore, the average power absorbed is 0 and some of the power value is negative. That is because negative value means that the coil is returning the stored energy back to the supply. It's like a direction. Okay, that's only for myself. Next, my co-partner will explain about the stimulation process. Thank you.
Okay, next is my name is Muhammad Syahmi and I will talk about simulation. And first is as you can see in this slide, there is two figure, figure 1 and figure 2. Okay, and first figure is the value that similar to the question, and the figure 2 is the circuit that we have put the value C and H that we calculate in this circuit. Okay, next is in figure 1 is the circuit that we choose. In this circuit, there is a value that cannot be used when we want to run this circuit. That is capacitor negative J2 and inductors J4. Then we use the software called Multisim. Calculate the value capacitor and inductance using formula SL equal to 2 pi FL and XC equal to 1 over 2 pi FC, and assume that the value of frequency is 60 Hz. Then in figure 2, we insert the value that we had calculated, and then we run the circuit and we place the power watt probe as 5 component and got the value of power average at each component, and then we record the reading in the multisim and compare to the calculate value, and as you can see, that is our calculation that we calculate, and this is the value of L and C. Okay, that is. Thank you.
Hi everyone, I am Niwash Kumar from section 4, where I am going to present about the results and the conclusion of our simulation. Usually, there are two techniques to find out results, which are simulation more to practical method and theoretical, which is more to mathematical calculation method. These two methods are commonly used to observe a difference between an actual value and produced value from error checking. Initially, there are two voltage supplies we used, where Vs1, which is equal to 40 volts and 60 Hz, and Vs2 20 volt and 60 Hz. Vs1 is produced average power of negative 61 watt and Vs2 resulted in negative 38.9 watt. After making some adjustment and modification, we noticed that we used an insignificant value for the inductor and capacitor. We also used a defined value for the theoretical method, which resulting a big margin difference from the both method. The average power absorbed by the resistor from calculation is 92.4 watts, which is slightly different from the calculation shown 99.9 watt, which is clearly stated in the table. The same method were used for inductor and capacitor, where inductor shows 0.038 watt in simulation, which is nearly 0 watt, as same as calculation. Whereas for the capacitor, the calculated value and simulated value differed in greater margin. As for the conclusion, we managed to perform the simulation we needed for the project. Multism is used to simulate the circuit we choose. Before we used multism to analyze the circuit, we used manual method in order to meet the question demand, which is the average power supplied and absorbed by each element. Based on the circuit given, the actual value of the some elements could not be used in the application by using these formulas. XL equal to 2 pi FL to search the impedance of inductor, and for the impedance of the capacitor we used 1 by 2 pi FC. The impedance value of capacitor and inductor could be obtained. If the theoretical calculation and result of simulation was same or nearly same, error could be prevented. We also learned how to use multism software and improved our manual calculation method. Thank you.